So far, we have been looking at the derivative of a function. Now let's look at the second derivative. Recall, the derivative of the function f of x is given by f prime of x equals the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And we saw that the derivative f prime of x is a function itself. Since f prime of x is a function, we can take its derivative. We can write this as f prime of x prime, but more simply as f prime prime of x, or f double prime of x. F double prime of x is called the second derivative of f of x. Let's now try to understand it. The derivative of f of x is the rate of change of f of x. In other words, f prime of x is the rate of change of f of x. Using that same logic, the derivative of f prime of x is the rate of change of f prime of x. In other words, f double prime of x, the second derivative, is the rate of change of f prime of x. So let's use what we just said, that f prime of x is the rate of change of f of x, and f double prime of x is the rate of change of f prime of x, to learn something new. Remember for the first derivative that f of x is increasing exactly when the first derivative is positive. So, f prime of x is increasing when the second derivative is positive, since the second derivative is the derivative of f prime. Now recall our definition that f of x is concave up if the rate of change of f of x is increasing. In other words, f of x is concave up if f prime of x is increasing, since f prime of x is the rate of change of f of x. What we just said, f prime of x is increasing when the second derivative is positive. So f of x is concave up if f double prime of x is positive. This gives us a quick and easy way to compute algebraically if a function is concave up. Let's use the same logic we did above to understand when f of x is concave down. Remember, f of x is decreasing when its derivative, f prime of x, is negative. So f prime of x is decreasing if its derivative, f double prime of x, is negative. Now remember our definition of concave down is that f of x is concave down if the rate of change of f of x is decreasing. But the rate of change of f of x is f prime of x. So f of x is concave down if f prime of x is decreasing. But we just saw that f prime of x is decreasing if its derivative, f double prime, is negative. So f of x is concave down if f double prime of x is negative. So to sum up, we have that f of x is concave up if its second derivative is positive, and f of x is concave down if its second derivative is negative. To put a picture to this idea, if the second derivative is positive, indicated by the two plus signs, then we are happy and concave up. However, if the second derivative is negative, then we are sad and concave down. We will now get a better understanding of what we just found, that f of x is concave up if f double prime of x is positive, and f of x is concave down if f double prime of x is negative, by simultaneously looking at the graphs of f of x, f prime of x, and f double prime of x. Our function starts out concave down as indicated with purple. We can see this in the first derivative because while it is positive, it is decreasing. And we can see this in the second derivative because it is negative. As we pass from concave down to concave up, the first derivative changes from decreasing to increasing, and the second derivative changes from negative to positive. Notice, as we pass from negative to positive, we have the point where f double prime of x equals 0. Notice in our graphs here that when f of x is concave down, f prime of x is decreasing, and f double prime of x is negative. Likewise, where f of x is concave up, f prime of x is increasing, and f double prime of x is positive. It is worth noticing the point indicated in red. In f of x, it is where we change from concave down to concave up. With f prime of x, it is where we change from decreasing to increasing, and in f double prime of x, we change from negative to positive. Understanding the relationships between these three graphs will help better our understanding of the relationships between f of x, f prime of x, and f double prime of x.